So today I'm going to show you how to use a machine learning algorithm to detect earthquakes. Before I start to share my research works, I want to quickly discuss about earthquake first. Have you ever experienced earthquakes? These two photos were taken in Taiwan in 1999 after the Chi earthquake. The magnitude of this earthquake is 7.7. It's an unforgettable memory for me because I lost some of my friends, classmates, because of these earthquakes. And this experience also made me decide to become a seismologist to investigate earthquakes. So, why do earthquakes occur? Earthquakes are usually caused when rocks underground suddenly breaks along a fault. And those earthquakes will generate seismic waves that make the ground shake. So on the map, the red star represents the location of earthquakes, and the triangle represents the seismic station. So the seismic wave will propagate in all directions, and the seismic station can record these seismic waves. The recordings we call seismograms. When you read the seismogram, there are two main types of the waves: body waves and the surface waves. Body waves can travel through the Earth in a layer, but the surface wave can only move along the surface of the Earth. Surface wave has the longest duration and the largest displacements of all the seismic waves. So when the Earth's surface wave travels through a region which is under the seismic stress, may trigger a local earthquakes. For example, on the map, it's a Chile earthquake, the red star, can trigger an open star local earthquake in California. So my research focusing on finding these trigger earthquake. Why? Because we don't have large earthquake every day. And the trigger earthquakes have very similar mechanism to these large earthquakes. So that's why studying these trigger earthquakes can help us to better understand earthquakes in general. However, these trigger earthquakes have relatively smaller amplitude, magnitude compared to a large earthquake. So the signal for these trigger earthquakes hidden in the surface wave. So we have to filter our data. Then we are able to find these trigger earthquakes. Once we found the possible trigger earthquake signal, we need to zoom into the data and to make sure it has earthquake characteristic. Then we can define it's a trigger earthquake signal. So this map shows right now we have thousands of seismic stations. That means one earthquake can be recorded by a single station or multiple seismic stations. So the number of available seismograms is staggering. As I mentioned before, we need to process our data by several steps. Then we are able to find the trigger earthquakes. So it's difficult for examining all the data by human experts. That's why we start to think its machine learning algorithm can help us detecting these earthquakes. In our study, we used 8 large earthquakes, and the seismic stations are located in California region, in the United States, and in the Himalaya, Tibet regions. In order to train our machine learning algorithm to recognize the trigger earthquake signal, we need to pre-label all the data. So if the data includes the trigger earthquake signal, we label it a positive example. And then if the data is very flat noise, then we label it a negative example. And we throw all the data to train our machine. We use convolutional neural network algorithm. This algorithm basically calculates the similarity between each example and try to push the data into a positive group or negative example groups. That's our final result. Overall, our machine learning algorithm can achieve above 90% accuracy. And then we also compare to our machine learning algorithm to another common way for detecting signal called signal-to-noise ratio, SNR. SNR is to computing the ratio between the signal in the surface window and the precise background noise. And the final result shown in this figure, our machine learning is more stable and reliable than signal-to-noise ratio method. Meanwhile, we are asking volunteers' help to identify these trigger earthquakes. So now we have a online citizen-sized project called Earthquake Detective. We convert these seismic waves to audio files, so people can easily listen by listening to the seismic wave to identify the trigger earthquake without having any seismological background. And you can use the link below the title and the QR code to find our project. Once we have enough data is classified, we can also use this data to train a better machine learning algorithm. And once data is enough classified, seismic models for how, when, where, why earthquake happened can be better tested. We sincerely invite all of you to become our volunteers. Thank you.